Okay, today we're going to go over properties of integrals. And before announcements, I went over these properties of integrals here. And we're going to, this power rule one is very useful. We're going to use this a lot. And then we're going to go through some exercises on these. So what I want you to do is we go through these subsequent problems. I want you to refer back to these. The main ones you're going to be using here are like this one here and this one here. And possibly the others too, but these will be sort of main ones, especially 4. So what I want you to do is go ahead and integrate this problem here, and I want you to work that out, and then in a couple minutes I'll go over this with you, how to do this one, okay? So remember, for this one here, you're going to be talking about rule 4 especially, but also rule 3, okay? I didn't mean to star 2 necessarily, but rule 3 and rule 4. Go ahead and work. You've already worked that one out?
I've done 1 and 2.
So Aaron has done 1 and 2. Let's see how you're working on this.
So we don't do 1 and 2, we just do 1.
No, you do 1 and 2. And there is a little acronym, a little mnemonic device that could help you with your integrating. It's called bump up and divide. Can you remember that? Bump up and divide?
I can remember that, right?
Bump up and divide. And so I'll show the relevance of that mnemonic device here in a minute or two. Okay, for number 1, the first thing I'm going to do is do a rewrite of this. I'm going to take this -6 out front, and so we have -6 out front and the integral of x cubed dx. You see that?
Yeah,
Okay.
I got that one.
Okay, good. So now we come up to the bump up and divide. So we have, our answer is going to be -6. And what we do is we take this x and we say bump up. We raise to a higher power. And we divide by that same power we raise to. And then we have plus our constant of integration c. And the last thing we can do is simplify. And so we're going to end up with the reduced form of this fraction, which would be like 3/2 x to the 4th power plus c. Does that look right?
That's fine. I didn't
That's
put
what you
the
got?
C. I didn't put the C.
Yeah, so let's remember the c, and then we can check if we got it right. We say, I'm going to just write this up as a sample check here, d dx of -3/2 x to the 4th, and the derivative of c is going to be 0 anyway, whatever c is. And so we can check our work by taking this 4. So we multiply 4 times -3 over 2, and we have x to the 3rd power. And what happens when we simplify all this? We get -6 x cubed. And so that's a check of our work, right? And we got back the original, and so that's good. So this is really a bread and butter of calculus, just like the power rule of differentiation is. So it's one that with practice becomes something that becomes automatic. You become an integrating machine, just like you become, I hope, a differentiation machine. All right, let's go number 2. Did you work out number 2? Yeah, Aaron said he did. Did you work out number 2?
You got it.
Do you have number 2?
I do.
I don't have it fully worked
I'll
out.
have it.
So just,
Tried.
Okay, well first, what I would do with this one is I have the difference of two terms here. So what I would do is I would go back and separate them according to trick number 5. And then one of the terms you'll have a coefficient that you can factor out, like here. And the last thing I would do is I would use rule 4 and fully integrate them. That's what I would do. So you'd be able to create two separate integrals out of this one. One here and one here. And then work that all out. So what I'd have here is I'd separate this out as x squared dx, and I'm going to have minus, I'm going to bring this 10 outside here, minus 10 x to the 4th dx. So do you see that so far? Does that make sense? So next the integrating of them, we're going to have for this one, what does this one become here? Okay, we have x cubed divided by
1.
3.
3, I mean.
Okay. And next, this one here is going to be,
I like 4, 5.
yeah, so Gavin's right about that. So we take this to the 5th divided by 5, and then what do we have to put out here too? Plus c. And here we separated this, and if we did each of these separately, they would each have their own plus c, right? But do you see that we combine when you do more than one as part of a single integral, even separated like this, that you still end up with just 1 plus c at the end? And then the only thing left to do here is simplify here. So we have like 1/3 x cubed minus 2x to the 5th power plus c. Did you get that for an answer? Did I make any mistakes? You got it for an answer? Is this a very difficult operation here?
For now.
For now it is, yeah. But it should be very simple. So this is one of the bread and butter simple things we do in calculus that
Dude, I could take some bread.
you can carry with you,
I can
right?
take some bread and butter. I'm so hungry.
Can you take some what?
Bread and butter.
Bread and butter. I'm making you hungry with saying about bread and
Sounds
butter.
delicious.
I'm not a, oh gosh, you got me, not from what I said, but from what your reaction is to what I said. You got me getting hungry too about it. I'm thinking of Pure Larson's bread with the butter she has, whose recipe I use sometimes. Maybe when they do the camp fundraising thing, I'll bring some by next semester. Okay, so now this one here, number 3, I want you to do number 3.
I think I got it.
You got it here?
Maybe, probably not.
What I would do here, first, I want to give you a little hint, is I would go ahead and do the calculus-friendly thing here first. I would take the 1/4 here, and then I would have the integral of x to the 1/2 power dx.
I don't know how to do number 4.
Okay, we'll get to number 4 in a minute. And Hannah was mentioning earlier today about a Kahoot game. Is this the perfect kind of thing to have a Kahoot game for?
See, have it ready by tomorrow.
Probably so. And if I don't have one, I'll tell you what. If I don't have one, I'll find one
Period.
that should work out, because that'd be a good.
And I will, here, I have to get this on video just in case you try to tell me tomorrow that that's not what you said.
No, because it is on video,
Oh, it is?
Ah.
Okay.
right? It is on video. This is going out.
Got that camera going.
I mean, it will be on video once it's
Oh,
uploaded.
Got
guys,
it.
talk about
So there'll be a.
from the past, the future.
This is how we celebrated Aaron's birthday last week, right?
1 half X.
Okay, so what we have is we have 1/4 we bring out here, and then we have X, and to bump up, what are we gonna have here?
1/2 plus 1 is 3/2.
3/2, and we divide by 3/2,
Which is multiplying by 2/3.
which is the same as, now Aaron said it,
There's the.
we divide by 3/2, which is the same as multiplying by 2/3. Okay, so whenever you bump up and it becomes a fraction, you can multiply by the reciprocal of that fraction and have your answer, and of course plus C. And then we can simplify where we can here. So we're going to have, is that like 1/6?
Yes.
So we're going to have 1/6. We're going to have, and we can rewrite this in a radical form like this, x to the 3rd power plus c. Is that what you got for that?
Yes.
Okay. Okay, so,
I didn't do like the right. I forgot.
yeah, did you leave it to the power of 3/2?
Yeah.
That's cool too, you can do that, that's all. This is, x to the power of 3/2 is just as correct
Yeah, I
as
put
the
X-
radical form.
X
The only reason I did that is because I had, when you can, you want to put the answer back in a form similar to the original.
Yeah, I put it all just over 6 instead of doing the 1/6.
Okay, so Aaron just put divided by 6, which is the same thing. So there'll be little differences in how you articulate the correct answer, but correct nonetheless. Okay, Aaron said he was had some problem with 4. Anybody else?
Yeah.
4? Anybody 4?
Looks tricky.
Now here, what you have here is you're going to have the integral of x squared over x squared dx plus 3, and so 3 integral of 1 over x squared dx. Do you see that thing? So we separated, and each of these was divided by x squared, and so this is what we have.
Oh,
Does that make sense?
yeah, I get that now.
Anybody have questions on that? So you take this denominator is common to both of these terms in the numerator, and so that's the separation. And so what you have here is you just have dx right here, and then you have plus 3. You're going to have x to the what power? -2 power dx. Okay? And now you can use that one rule we had,
Oh, and that just equals C, right?
equals x. And then this here, we're going to get plus 3. And what is the bump up here? It's going to be x to the -1. And then we're going to divide by what we bumped up to. So we can divide by -1, which is the same as multiplying by -1. And then we have the plus c right over here. And now we can just give our answer, our final answer. We have x, and we have minus 3 over x plus c. And so that's going to be our integrated, our final answer as far as we can go on that.
We should have a Kahoot game as our final exam.
Okay,
I'm
yeah,
not
that's not
gonna,
gonna,
sorry.
And
No.
it's like whoever gets first gets 100, whoever gets second gets like a 95.
It's a 0.
Whoever gets third gets a 90, fourth and
That's not fair to me, because I
85,
can't read the Kahoot.
fourth
Yeah.
and 85, and fifth and 80. So the lowest grade we get is me.
okay, we have, now, Hannah,
How about Hannah just?
I'd rather team up.
what we'll do, Hannah, is I have an idea for you,
How about
Hannah.
I just play the Kahoot?
No, this is the idea, Hannah, is continue going to school, continue advancing in your career, and qualify to become a teacher of mathematics.
I don't wanna do that either.
You don't want to do that? You want to be like your mom? But then you can do the
Coop
coop game.
every single day.
But that is really a good, I think hoop games are great. They can really help you learn a lot. And really in different subjects, and it's really good for calculus. I think it is. And for the types of math that I do in my other classes. Yeah, and what it is, it gives, I think it's really good. So I think we'll do it tomorrow. Okay, next, and we're just about with time to the end of class, but we're going to talk about particular solutions. And I think, didn't we talk yesterday about general solutions? Didn't we? So now we're talking about particular solutions. And basically what you have, particular solution is like an integral, but it's where you're given enough information to actually get an answer where you don't have to put plus c. And so that's what it is. So you're given enough information to that. And so you can see what that is here. You integrate f of x, and then you find y equals f of x using the point to solve for c. And so you're given additional information to find what c is, and effectively it makes of this not an indefinite integral, but a definite answer because of additional information. So that's what we're talking about here. And then you're going to see kind of the process here. It gives a process. We're going to just kind of finish with this today. And here, what we have says find the particular solution of y if y prime equals 3x squared minus 1 is passing through 2, 4. And so how do we find y from y prime? What is y equal to? Well, y is going to be equal to the integral of y prime dx. Okay, remember we had this, if we had this f of x, big F of x, is equal to the integral of small f of x, right? So this is a similar type of pattern. So if we go ahead and also we're going to have, after we take the integral, we're going to have plus c at the end of it. So let's go ahead and work that out. So we have y is equal to the integral of 3x squared minus 1 dx. And what is the integral of that going to be? Well, it's going to be y equals 3 integral of x squared dx minus 1 dx. Okay? And then what is the integral of this going to be here? When we work this out, we have 3. What is the integral of this? So we have x to the third divided by 3. So we divide by what we take the power to. And then this is going to be minus, what's the integral of dx? X plus c. And so this will cancel out. And so now we have enough information, don't we, to solve. What can we do with this thing?
Plug in 2 through 2.
We plug in this stuff here, right? So we have 4 is equal to 2 to the third power minus 2 plus c. I'm going to leave myself some room here. And this thing right here, I'm going to box in. This is called your general solution. This is called your general solution right here. Okay, so let's continue here to get our particular solution. Now, so we have 4 is equal to, that's going to be, is that 8? 8 minus 2 plus c. So that's going to be 4 is equal to 6 plus c. So c is equal to? Negative 2. So now we can write our particular solution, which is what? y equals x cubed minus x minus 2. So this is called, this is particular, so I call this one here general solution. And this one over here is called particular solution. And really, that's all there is to it. So, yeah, and we'll pass through there, so that will be good. Anyway, that is probably a good place for us right now. Yeah, we'll start working on this one tomorrow, and that's it.
That's not hard at all.
That shouldn't be too bad.